The Mathematics of the Gods. A 2025 study of a previously overlooked mural in Palenque's Temple of the Cross revealed advanced base 20 mathematical calculations tracking Jupiter's 4 largest moons with 98% accuracy relative to modern astronomy. What makes this extraordinary is that 3 of these moons, Io, Europa, and Ganymede, require telescopes to observe. The mural's calculations span 1,706 days, precisely matching Jupiter's orbital cycle from Earth's perspective. This wasn't simple stargazing. It was celestial computation on par with modern algorithms. The Maya's vigesimal, base 20, system enabled such precision. Their dots and bars could represent values up to 10 to the power of 60, while a shell symbol denoted 0 centuries before other civilizations developed the concept. At Zoltan, archaeologists found numerical tables spanning 7,000 years, using 177 and 148-day sequences to predict eclipses, complete with corrections for Earth's slowing rotation that modern science only confirmed recently. Their mathematical prowess appears everywhere from market transactions to cosmic calculations. The Dresden Codex contains multiplication tables showing compound interest over 50 years and land measurement algorithms matching modern survey techniques. One Venus table demonstrates understanding of planetary motion ratios by converting between synodic and orbital periods through multiplication by 1.6. Physical evidence confirms their computational methods. At Köppen, carved counting stones form a base 20 abacus capable of solving quadratic equations. The stones' positions mirror coefficients in the Dresden Codex eclipse tables, proving they maintain both abstract and practical calculation systems. This mathematical sophistication shaped their world. Uxmal's governor's palace contains 24,000 stones, precisely cut to BASE 20 Hunab units, 42.5 centimeters. The structure's proportions resolve to perfect fractions only visible in their numbering system. Similar precision appears in ceramic volumes, road widths, and field divisions, a mathematical fingerprint across their civilization. A training facility at El Mirador revealed how they developed these skills. Over 100 practice tablets show students progressing from basic arithmetic to polynomial equations. One advanced tablet derives the sphere-to-cylinder volume ratio 400 years before Archimedes, suggesting mathematics served primarily astronomical purposes given the facility's proximity to an observatory. Their calendar system demonstrates extraordinary computational ability. The calendar round synchronized 260-day and 365-day cycles flawlessly for millennia, while the long count tracked days linearly using multiplicative periods up to 144,000 days. Modern computers confirm this system maintains perfect astronomical alignment over its 5,125-year cycle. The system's perfection raises intriguing questions. The base 20 structure matches finger and toe counting, yet neighboring cultures use different bases. The 0 symbol appears fully formed without evolutionary stages. Even artistic designs encoded mathematical constants. A Tikal ruler's femur bears pi accurate to 4 decimal places in base 20, while another artifact shows the square root of 2 with 99.9% precision. This knowledge wasn't confined to elites. Modern indigenous communities still use base 20 calculations with astronomical corrections matching ancient codices. The continuity suggests mathematics permeated all levels of Maya society. The implications challenge historical assumptions. A civilization without metal tools or draft animals developed mathematics, rivaling 18th century Europe. Their system's cosmic precision seems too advanced for gradual development. The Temple of Kukulkan's newly discovered chamber adds to the mystery, with carvings showing instruction in spherical geometry using planetary models. Modern technology finally reveals the full scope of their achievements. Electron microscopy exposed hidden notations in the Dresden Codex showing calculation steps, while 3D imaging revealed thousands of erased computations, a mathematical palimpsest. Supercomputers confirmed their eclipse predictions surpassed all contemporary records. How they achieved this with available technology remains archaeology's greatest mathematical mystery. Their legacy endures not just in numbers, but in challenging our understanding of human intellectual potential. The pyramid known as El Castillo at Chichen Itza demonstrates the Maya's extraordinary astronomical knowledge through its precise architectural features. Each of its 4 sides has 91 steps, totaling 364 steps when combined, with the upper platform completing a 365-day solar year representation. The pyramid's cardinal alignment within 0.5 degrees of true north creates remarkable celestial interactions. During equinoxes, the northern staircase transforms into a descending serpent as triangular shadows connect with stone carvings at the base. an effect requiring exact step measurements of 16.8 centimeters rise and 30 centimeters tread depth. Beyond visual phenomena, the pyramid functions as an acoustic marvel. Its staircases act as natural sound waveguides, transforming a simple hand clap at the base into the chirped echo of a quetzal bird. This effect, created by the precise 45-degree staircase angle and height-to-width ratio, changes predictably throughout the day. Whispered words travel upwards with surprising clarity, while specific frequencies between 110 to 115 Hz resonate powerfully through the structure, like a stone orchestra tuned to nature's rhythms. Thermal imaging reveals another layer of sophistication. The pyramid maintains a constant 22 to 24 degrees Celsius in interior chambers through passive ventilation channels, despite external temperatures reaching 38 degrees Celsius. This natural climate control system, operational centuries after construction, uses pressure differentials created by the pyramid's shape and orientation to prevailing winds. Hidden within El Castillo's core, ground-penetrating radar uncovered two smaller pyramids. The innermost structure from 600 AD already displayed precise cardinal alignment, with subsequent construction phases maintaining these astronomical orientations while expanding outward. Builders selected limestone blocks containing microscopic fossils that refract light to enhance the equinox shadow effects, evidence of advanced material science knowledge. The pyramid's dimensions encode mathematical relationships that persist across measurement systems. Its base perimeter equals exactly 24 times the height-to-base ratio of the Great Pyramid at Giza, while the structure's volume measures precisely 1/4 of its surface area in Maya units. These proportional relationships suggest intentional design rather than coincidence. Recent excavations uncovered tools used for maintaining the pyramid's astronomical functions: limestone adjusting implements and polishing stones buried beneath the northwest corner. Ceramic fragments nearby depict workers engaged in alignment verification rituals, showing active preservation of the pyramid's precision across generations. Rainwater management systems demonstrate additional engineering prowess. Runoff channels along staircases direct water to collection points that correlate with carved markers, producing auditory frequencies matching Maya ceremonial music during heavy rains. The water ultimately feeds an underground cenote beneath the pyramid's center. The pyramid's alignments extend beyond solar events to lunar cycles. During major lunar standstills every 18.6 years, moonlight creates shadow patterns mirroring the solar equinox effect in reverse. Contemporary Maya elders maintain oral histories describing centuries of observing these phenomena, matching archaeological evidence of the structure's functions. Modern analysis confirms the impossibility of achieving such precision through trial and error, akin to building a modern skyscraper without blueprints. Computer simulations show the Maya needed celestial mechanics knowledge comparable to 16th century European astronomy to create these effects. The absence of developmental prototypes suggests this knowledge appeared in completed form. The pyramid's 1842 rediscovery during a Venus transit event mirrors ancient Maya practices of timing events to celestial phenomena. Continued study may reveal additional alignments tracking Mercury or even the 26,000-year precession cycle, a concept modern science only verified recently. El Castillo stands as tangible evidence of astronomical and architectural sophistication that contradicts conventional narratives about ancient civilizations. Whether from indigenous development or inherited knowledge, the pyramid's silent testimony to celestial understanding remained unmatched for nearly a millennium. The Obsidian mirrors. The 2025 excavation at Copen Structure 10L16 uncovered 12 polished obsidian mirrors buried beneath the main plaza, each measuring 15 to 23 centimeters in diameter with remarkable surface flatness under 0.02 millimeters. These precision-crafted objects rested on carved limestone stands arranged around 3 elite rulers identified by their jade dentil inlays. The mirror's optical quality rivals modern telescopes in specific applications. Testing showed they could reflect starlight with 94% accuracy, projecting recognizable constellations like the Turtle, Orion, and Rattlesnake, Scorpius. NASA confirmed their ability to track comet paths when rotated at calculated intervals. One mirror with magnetite inclusions even demonstrated unique reflective properties during Venus transits, functionality comparable to polarized lenses today. Manufacturing analysis reveals why these mirrors outperformed typical reflective surfaces. Craftsmen selected obsidian nodules from Guatemala's El Chayo quarry with less than 0.3% gas bubbles, then ground them using progressively finer abrasives from quartz to powdered jadeite. The 8-stage polishing process, ending with vegetable oil treatments, created surfaces so smooth that 3 primary mirrors could resolve binary star systems invisible to the naked eye. Their burial context confirms astronomical use. Microscopic pitting shows 5 mirrors endured long-term outdoor exposure, while calibration marks on one specimen divide its circumference into 260 segments, matching the Solkin calendar. Accompanying stone stands with degree gradations suggest adjustable mounting, and murals depict rulers using mirrors to observe constellations accurate for Köppen's latitude. The mirrors arrangement reveals sophisticated design. Positioned in a circle with 30-degree spacing, reflecting Maya mathematics, 3 primary mirrors aligned to cardinal directions could theoretically track celestial movements across the entire night sky. This configuration functions similarly to modern telescope arrays when experimentally reconstructed. Historical records corroborate their purpose. The Madrid Codex describes dark stones that show the sky, used for predicting planetary movements, while Corrigo texts link mirror observations to architectural timing. Contemporary Chordi elders' stories of ancestors using sky mirrors to communicate with celestial beings strikingly parallel these finds. Spectral analysis uncovered advanced modifications. 7 mirrors contain mercury-like compounds deposited in geometric patterns, primitive reflective coatings enhancing specific wavelengths. Another's intentional scoring marks produce diffraction patterns matching Venus's cycle, suggesting purposeful optical engineering. The mirror's sudden technological perfection puzzles researchers. Modern attempts to recreate them using period-appropriate methods take months yet achieve only 80% reflectivity. Their abrupt appearance in the archaeological record contrasts with gradual development seen in other Maya technologies. Ceremonial deposits beneath the mirrors deepen the mystery. A cache of 584 jade beads arranged to match Venus's synodic period suggests intentional burial during significant astronomical events. Structure 10L-16's platform, leveled to 0.1 degrees of horizontal with solstice alignments, created illumination effects confirming its dual role as observatory and ritual space. These discoveries force re-evaluation of Maya scientific capabilities. Previously dismissed obsidian artifacts in museums now warrant re-examination, with 3 already confirmed as comparable precision instruments. Harvard experiments showed properly arranged mirrors could predict lunar eclipses, requiring coordinated teamwork akin to modern observatory crews. The Köppen mirrors demonstrate systematic celestial tracking with precision instruments, challenging assumptions about pre-Columbian technology. Their existence suggests either centuries of accumulated knowledge or access to lost techniques. As research continues, these artifacts may reveal more about how ancient cultures achieved such advanced astronomical understanding without modern tools. Ongoing studies examine potential connections between mirror placement and underground water systems, while future excavations may uncover manufacturing workshops that could explain their remarkable production methods. These finds highlight how much remains undiscovered about Maya scientific achievements. Each discovery reveals greater complexity in their understanding of optics and celestial mechanics, compelling us to reconsider the boundaries of ancient technological innovation. The mirrors stand as physical evidence of sophisticated knowledge that contradicts conventional narratives about pre-Columbian scientific development.